Hello everyone. So, uh, I'm going to give the presentation on this research paper, which is the name is Towards All-in-One Pre-Training via Maximizing Multi-modal Mutual Information. So, in this research paper is about how we can train the model so it can like the complexities decrease of the by training the model, and in the less time the model will give a good performance rather than the traditional models. So let's go forward with the abstracts. So the unified training approach means the traditional training methods for deep learning models often involve several stages, each focusing on different aspects like feature extraction, fine tuning, etc. However, M3I pre-training simplifies this process by integrating various stages into single stage. This means that instead of having to go through multiple stages, M3I combines these steps into one cohesive training approach, making the process more streamlined and efficient. So, this is the regarding the research paper, like the new method called M3I, which reduce the multi-stages training into the single stage so that the model will be trained with more efficiently. So this is about the benefits like the performance boost, like the M3I training outperform previous methods in tasks like image classification, object detection, and semantic segmentation, and achieving more than state-of-art result even with, and also it is useful to train the billion parameters of model. Okay. So generally it develops a formula so that we can share the information for the image to text and regarding that. Yeah. So let's move to the next slide, which is introduction. So in the introduction, there is 4 points we will discuss about, like theoretical foundation, M3I pre-training innovation, exploratory performance, and streamlined training process. So theoretical foundation is understanding the theoretical underpinning of large-scale pre-training methods reveals a common optimization objective, like maximizing mutual information between input and target representation. This insight forms the basics for developing a unified pre-training framework. So M3I pre-training innovation is introduce a groundbreaking single-stage approach that harness the strength of diverse pre-training strategies by extending the mutual information framework to accommodate multiple inputs and targets. So M3I pre-training efficiently incorporates various supervision signals, and it also gives the exploratory performance, like it demonstrates the superiority of M3 pre-training, notably pre-training billion of parameter model like uh, inter-image edge leads to unprecedented performance on fundamental detection and segmentation tasks. So surpassing previous benchmark, this training method gives a very good results. And we generally follow the streamlined training process, the simplifies the training pipeline by consolidating complex multi-stage approach into the single stage, as we discussed in the previous slides. So this is what about the concept we are going to discuss. So here this is the different type of training methods, like the supervised pre-training, which is generally trained on the label data, and another one is the weekly supervised pre-training, which means there is a label data, but many of the data is unlabeled. So there is about that, and this is self-supervised pre-training, which include the intraview and interview. Intraview means it is focused on the single view, and the interview focus on the multi-view. So generally, we believe that in the interview, so the model get from information from the multiple sources, so it will be very good for that. And intraview means the accuracy will be increased as it only focus on the single view. So, and the M3I pre-training means that is a combination of all these methods. So it will give us a output with the single stage pre-training. So this is about. So let's move forward second slides. So as I discussed in the previous slide, so generally this is a supervised pre-training. So like this approach involves training a model on a data set where each input is associated with corresponding target label. For example, an image classification and object detection. The second one is self-supervised pre-training. Like self is a form of the pre-training where the model learns from the data itself without require external label. Weekly supervised learning, like we described it, it is falls between supervised and self-supervised learning. So multitask mean like we can get the multiple target from a single input and multi-stage that the multiple stages are included in the training work. So let us discuss about the method. Like the first we discuss about the mutual information for generic pre-training. Okay. So it is the theoretical framework for generic pre-training and encompassing various pre-training paradigms such as supervised, weekly supervised, self-supervised. So let us try with the objective of pre-training. So the primary goal of pre-training is to learn representation that effectively capture the underlying structure of the training data, and this achieved by the maximizing the conditional mutual information between the encoded representation of input and target data. The second one is like mutual information maximization. So the objective function for pre-training is formulated as maximization of conditional mutual information between the input and output. So this is generally include the regularization term to prevent representation collapse and predict term to ensure that a good distribution of the input and output. So it is also include the approximation of posterior distribution. So the posterior distribution is often interactable and approximation using another parameterized distribution is introduced. So the approximation enables the formulation of the pre-training objective as maximization problem involving an approximated posterior distribution. So the training loss derivation is also important factor. The training loss derivation based on the maximization of mutual information. So so that we can like try to minimize the loss and the in instantiation into different pre-training paradigm, like the generic pre-training loss derived can be instantiated into various pre-training paradigm by incorporating different mechanism to avoid representational collapse and adapt to scientific data distribution. So this allows the framework to accommodate supervised, weekly supervised, and self-supervised pre-training. Overall, these theoretical frameworks provide a comprehensive understanding of how different pre-training paradigm can be unified under a common optimization objective. Okay, so let's move forward. Second, third, and fourth point. So the second point is about connecting with the existing pre-training methods. So existing pre-training method encompass supervised, weekly supervised, and self-supervised approach, each tailored to different data types and objectives. So supervised pre-training focuses on image classification tasks utilizing annotated categories as targets. The weekly supervised exemplified by contrastive language image pre-training and leverage image text pair from the internet to enable versatile tasks like open vocabulary recognition, and self-supervised learns from the image alone and employing various augmentation strategies. So multi-input, multi-target pre-training is like to leverage the strength of different pre-training paradigm. The framework is extended to multi-input, multi-target setting. This approach allows the optimization of objective for various types of target simulation by splitting target into non-overlapping group and encoding them independently. The pre-training process can effectively capture diverse properties of the data. So multi-input pre-training utilize multiple inputs with one target for each input. An enabling technique like mix-up of cut mix to enhance model accuracy and generalization. So last we talk about the M3I pre-training. So M3I pre-training built upon the mutual information framework systematically integrate different pre-training paradigm into one unified approach. It utilizes two input and four targets, combining self-supervised learning with supervised or weakly supervised pre-training. The input encoder mix input views using a randomized binary mask and encodes them with an image backbone. Target encoder produces the target representation employing momentum, image backbones, or image targets and categories embedding text backbones, category text targets. So this approach enables intra-view and inter-view self-supervised prediction, allowing one image to predict the same view while the other predicts a different augmented view. Overall, M3I pre-training combines the strength of various pre-training methods, offering a comprehensive framework for effective representation. So let us go in towards the experiments. So in the experiments, there are 3 points we discuss about, like pre-training of 1B image backbone. So it is utilizing the inter and image edge convoluted based image backbone with 1 billion parameters. So our pre-training approach achieved remarkable result unlike previous methods which rely on complex multi-stage pipelines. So M3I pre-training offers a single yet highly effective single stage paradigm. This approach outperforms existing method in COCO object detection, LVIS long tail object detection, and ADE20K semantic segmentation while exhibiting competitive performance in ImageNet classification. So the, the experience showed that the M3I performed really well. So let we discuss about the ablation study. So the ablation study investigates various aspects of the pre-training process. Firstly, regarding self-supervised pre-training, the study examined different factors including mask input, target representation, and intra-view versus interview pre-training, as we discussed in the uh, first slides. So the mask input provide crucial for both intra-view and interview pre-training, significantly enhancing model performance. And dense feature targets outperform the global feature targets, so enabling spatial discrimination and semantic alignment capability. So the choice between interview and interview pre-training depends on whether mask or full input is used, with both optional achieving good performance under certain conditions. Secondly, the study explored the multi-input, multi-target pre-training, comparing M3I pre-training with single-input, single-target pre-training method. M3I pre-training without mixing demonstrates superior or comparable result across all tasks. So especially excelling on LVIS and AD20K benchmark, combining different pre-training method. M3I pre-training proves effective due to their focus on different representation properties, leading to improved performance across all the tasks. So this study also described that the M3I performed really well, and the last one is a system level comparison with other methods, like in the comparison with previous method using the same VITB16 image backbone. M3I pre-training demonstrate competitive performance across the various dataset, including ImageNet, COCO, LVIC, and ADE20K. So each pre-training method offers distinct advantage, like supervised training, excel in semantic alignment, weekly supervised enable zero shot transfer. So all the method performing very well on the different tasks. So let's move forward with the conclusion. So the mod in the conclusion we discussed that the modern large scale network relying on combining different pre-training method to effectively utilize massive data, which suffers from the multi-stage pre-training practice. To derive a single stage pre-training, we propose a generic pre-training framework that unifies mainstream pre-training approach. We further extended the framework to a multi-input, multi-target setting, which shows that the previous multitask pre-training method are actually optimizing a lower bound of mutual information. Finally, we propose an all-in-one pre-training method M3I pre-training. So the M3I pre-training surpassed previous pre-training method in various transfer learning settings. So one limitation is that we focus on vision-centric pre-training. So the proposed framework can be applied to other domains like natural language processing or visual linguistic tasks. We accept to explore other domains in the future work. So this is about uh, this research paper. Thank you very much.